Hello, good evening everyone. Good evening everyone. I welcome all of you to Gradeup channel of YouTube. So join together for fantastic questions on thick and thin shell, column. So you are watching Gradeup channel of YouTube and learning with me myself MD Ansari, that is your civil champion study plan. All of you please join together. All of you please join together and let us start our. Please share it and press the like button also. Okay. Am I audible to all of you? Hello Abhishek, good evening. Hello Neha, good evening. Okay, let us start now. Hello Kavya. Please share it. Okay. I hope all of you are doing good and staying safe. See, this time along with the gate examination, you have engineering services also. So those who are doing that, this champion study plan, they will get benefit in their ES prelims preparation also. So the number wise, the weightage for strength of material in engineering services are more compared to gate. Although gate has some intangible benefits already, every time you will be getting it by completing the strength of material, either you are preparing for gate examination or maybe for the ES examination. Now let us start the session now. This is my small introduction. You can join me there in Civil by Ansari Sir in a Telegram channel. There is a vision batch for 2022 and 2023. Both are going on for GATE and ES. One can join there and subscribe either for Hindi or English. Both batches are going on. These are the star faculty of the Gradeup. And there's a GATE champion study plan which I told you. To get the maximum benefit, remember the courses are going on app at 11 a.m. and that is the theoretical one, and the practice session is going on YouTube. At the same time, if you'll go to the description box, you'll find that there is a schedule, and over that schedule everything is now stacked in a proper sequence, so you get the most benefit by going to the schedule on your description box. There's a mega mock challenge and only one test is now remaining, that is on 29th of August, that is for bark. So first question in front of you: two closed thin vessels, one cylindrical and other spherical with equal internal diameter and wall thickness, are subjected to equal internal fluid pressure. The ratio of hoop stress in the cylindrical to sphere will be. What will be the ratio? What will be the ratio of? Can you do this one? What is the hoop stress? See, always one should remember that. For a cylindrical one, what is the formula for hoop stress? Hoop stress. So if you are not able to remember, sometimes if you are getting confused, it is a PD by 40 or PD by 2T, isn't it? PD by 2T and PD by 4T. So remember that for hoop stress, actually it is, just a second, I'll just adjust my video. Okay. So always remember that your hoop stress is always more. So that hoop stress for a cylindrical one is nothing but PD by 2T, and for the longitudinal stress for the cylindrical one is PD by 4T. And it is same, it is like, PD by 4T and PD by 2T. And for, if you see that for the spherical one, for the spherical one, it has the same longitudinal as well as hoop stress, isn't it? Spherical has same in both the directions. So either you talk about longitudinal or spherical, he is asking about longitudinal or spherical, it has only one, that is PD by 4T. Now what is the ratio of hoop stress in cylindrical? This is hoop stress in cylindrical. What is that? PD by 2T, PD by 2T divided by PD by 4T, and finally you are going to get 2. Yes, absolutely correct. A thin cylindrical steel pressure vessel of diameter 6 cm and wall thickness 3 mm, this is 3 mm, is subjected to an internal pressure intensity of P. If the ultimate strength of the steel is 3600 kg per meter square, this is your kg per centimeter square, I think. Kg per centimeter square, you take it as kg per centimeter square, kg per centimeter square. Then what will be the bursting pressure? What is the maximum pressure which you can apply there? What is the maximum pressure, internal pressure which you can apply there? Just now I told you that for a cylindrical vessel, the hoop stress is nothing but PD by 2T, and the longitudinal stress is nothing but PD by 4T. Now the cylinder, if you are talking about, cylinder will be made up of only one material. So the problem is that if it is made up of only one material, either you go for the hoop stress or the longitudinal stress over the element here. The failure will occur only at 3600. That is the ultimate maximum which you can apply. So if you will apply any of the pressure, the maximum will develop is nothing but your hoop stress. So let us just do the designing for the hoop with utilizing the hoop stress only. Are you able to understand that? If you increase the constant pressure, if the diameter and thickness all are same, the hoop and longitudinal, always the hoop stress generates more for a constant pressure. The internal pressure, always the hoop stress will be generated more. So do it for the hoop stress only. Now instead of the hoop stress, keep your ultimate or final value which you can maximum you can apply. The maximum stress which you can apply is nothing but 3600 kg per centimeter square. The internal pressure is asked to you. The dia is given as 6 centimeter. Dia is 6, right? Okay, 6 centimeter divided by 2 into 3 mm is the thickness. You can write down as 0.3. If you will calculate from here how much you are going to get, 0.3 into 2 into 3600 divided by 6. So 6, but here it will come. So you will get 10 will get, so 360 kg per centimeter square. That's all. So remember that it is always to compare with. These are the easy problem. Now try this one. These were the easy problem, and before trying it, please share it. A 10 mm thick cylinder. Now this is thick cylinder. Shell made up of steel has a maximum permissible tensile stress 140 Newton per mm square. The efficiency of the longitudinal and circumferential joints are 65% and 35% respectively. Determine the maximum permissible dia of the shell if internal fluid pressure is 3.5 megapascal. Please do not forget to share it. Please share it with your friends so that they will also get the maximum benefit, isn't it? Now what you'll do here? What is the meaning of your efficiency of your joint? See, if you have a cylindrical vessel, one should understand that if it is your cylindrical vessel, if you are talking about a longitudinal stress will be related to longitudinal stress will be related to the circumferential joint efficiency. Circumferential joint efficiency. Are you able to understand that? You will be having another portion of the cylinder here. Now, if I'm talking about the longitudinal stress, which is over this I'm talking about this element, it is better to go with, just a moment. It is better to go with this one. This diagram is more convincing. Suppose this is your cylindrical vessel. Keep this one inside. Now, this is more convincing. Now, if I'm talking about longitudinal stress, so a circumferential joint efficiency matters with the longitudinal stress. Agree or not? Agree or not? Take the element here. This is the diagram just created for your more understanding. This is one element if you are considering at this location. This will depend on the efficiency of your joint which is given in your circumference. So circumferential efficiency, what is that circumferential efficiency? That is 35%. That will matter for your longitudinal stress. And if you are talking about the hoop stress, now if you are talking about the hoop stress, just let me draw another diagram. If you are talking about hoop stress, then a longitudinal joint efficiency matters to you. Are you able to understand this? First of all, you should understand that a longitudinal joint efficiency matters to you for hoop stress, and a circumferential joint efficiency matters to you for longitudinal stress. So if you consider any of the element here, this is one of the element you are going to consider maybe here. Now here the hoop stress will be transferred completely if you have till the material strength of the material, if you have a nice longitudinal joint. Are you getting my point? Now if I'll be writing down the equation, I'll write it down now. The hoop stress. Now this is the permissible. Instead of the permissible, if you write down here, but see, this is permissible, right? Hoop permissible. Permissible for a material is same for both. It is made up of same material. Of course, the material permissible limit will be same. But here for the hoop, I will multiply with the efficiency which is there in the longitudinal direction. So efficiency in the longitudinal direction, that is the permissible limit you have now. And for the hoop, you already know that is PD by 2T. Are you able to understand that? And another equation, if you write it down, the another one is your longitudinal stress for the permissible. These are same. Permissible limit for the hoop and longitudinal both are same, right? Now here you will be writing down the efficiency which is there in your circumferential. That is now PD by 4T. Use these two equations. Are you able to understand that? Please let me know. Very important. This is your element. Over the element, here you have a longitudinal stress, and over this element you have a hoop stress. This is sigma H and this is sigma L. Is it clear? See, solution is okay. One can do the solution. The main thing is that whether you are able to understand it or not. Now, just do that one. That's simple. He has given already a 10 mm thick cylindrical shell made up of steel has maximum permissible stress 140. Put 140 here, 140 here. Efficiency you have given here and here. Then you have to determine the maximal permissible diameter. The diameter you will now just calculate one. I'll calculate just now. Right. First keep it in equation 1. So permissible is 140 multiplied by efficiency in the longitudinal direction is 65%. See that. The more important is that do not get confused with the longitudinal and circumferential word. Efficiency in the longitudinal is 0.65. That is the maximum stress which you can apply in the hoop stress. This is your hoop stress. And this is your longitudinal joint. Here is your longitudinal joint. Either maybe through welding or maybe some kind of arrangement, right? Now, into 0.65. Then pressure, internal pressure given as 3.5 megapascal. I will not change it to it because it is Newton per mm square, into D divided by 2 into thickness is given as 10 mm. Now you calculate how much D you are getting it from here. How much D dia, how much dia you are getting it from here. That is 140 multiplied by 0.65 multiplied by 20 divided by 3.5, and you are going to get 520 mm. Use the second equation also. Second one, keep the values here. That is 140 into 0.35 equals to 3.5 into dia divided by 2 into 10. How much you will be getting it here? How much you will be getting it here? That is 140 multiplied by 0.35 into 2 into divided by, you will get 326. Oh, I think somewhere some mistake in calculation. Oh sorry, this is 4, no? This is 4, I'm sorry, this is 4. So how much you'll be getting finally? Around 700 or something like that. 140 into 2, sorry, 20 into 0.35, 140 into 0.35 into 40 divided by 3.5, and here you are getting 560, isn't it? 560. So you are getting two values, that is 560 mm if you are using the second equation and 520 mm if you are using the first equation. Which one you will use? Which dia you will be using it? Of course the lesser dia, isn't it? Of course the lesser dia will be utilized. Although 560 is not here, but even though 560 is present here, you are not going to use the maximum dia, right? If you use the more dia, more stresses will be generated, isn't it? So now you can see it in other way also. In other way, generally you will find that equation will be written like hoop stress will be PD by 2T into efficiency, that is longitudinal efficiency, and for the longitudinal stress, the PD divided by 4T into efficiency in the circumferential one. This is the equation. Now more dia, if you are going to use, more stresses will generate. One cannot use the more dia, otherwise in another way your material will get fail. Your material will get failed. Are you able to understand it? So easy problems are also there, moderate problems are also there. One should practice all the type of problems, isn't it? If you have any doubt, please let me know. Is it clear to all of you? Okay, next one. Here is your next one. Here is your next one. What is that? Okay. A thin cylindrical shell of internal dia D and thickness T is subjected to internal pressure P. The change in diameter. The change in diameter. Can you do this one? What will be the change in diameter? Okay, see here, see one thing, the change in diameter, actually you are actually searching for delta D. I'll say that change in perimeter from the suppose this is your cylindrical shell, and consider one element over here. That element will be your having a hoop stress and as well as longitudinal stress, right? It will be having hoop stress and longitudinal stress. Take the element out. This is the state of stress it has. In a diameter wise, it has a hoop stress, and in longitudinal side, it has a longitudinal stress. Correct, no? Now, if you are searching for delta D, one can always calculate delta D by D. That is nothing but strain. This is nothing but your actually, what is actually, this is circumferential strain. How it is a circumferential strain, I'll write down. Circumferential strain. What is that circumferential strain? That is nothing but, suppose a dia initial is D So the perimeter initial will be pi d. If delta d will be increased, a new perimeter will become pi d plus delta d. Correct? No? And the previous perimeter was pi d. Divide, that is a change in the perimeter. The top I have written change in the perimeter divided by change in perimeter divided by initial perimeter. Now if you solve this, simplify this, you will find that delta d by d. Now delta d by d is nothing but you have a circumferential strain, and now you see that for the state of stress circumferential strain, how you can calculate the circumferential strain can be calculated as sigma h is actually trying to increase that one, and sigma l is actually trying to decrease that one. So I can write down from the help of Poisson's ratio sigma h by E and minus of mu times sigma L by E. Are you able to understand that? Now hoop stress and longitudinal stress already we have, right? Hoop stress and longitudinal stress just now I have given it to you. If you will keep those values here, just keep those values here. What was the hoop stress? Hoop stress was PD by 2T minus mu times what was the longitudinal stress, that is PD by 4T. Now you take common PD by 4TE, you can take as a common, and you'll get 1/2 minus mu. That's all. This is nothing but your change in diameter by diameter. He is not asking the strain in diameter. Understand that delta d by d is circumferential strain as well as strain in diameter, right? Diametric strain also I can say that it is circumferential strain or diametric strain, but he is asking about what is the change in diameter. So change in diameter will become PD square by 4TE. Agree or not? Multiply with this D and you get PD square by 4TE 2 minus mu. So answer will be B. Did you get that? Please let me know if you have any doubt here. Is it clear? Okay, now solve this one. A thin cylindrical shell of internal diameter d and thickness t is subjected to internal pressure P. The volumetric strain. Now they all are like, what will be the volumetric strain? Can you tell me? Which one is correct here? Yes, I'm just waiting for your comments. What will be the volumetric strain? Yes, Rahul, actually you are correct. Yes, all of you are, I hope, correct. All of you are correct. So volumetric strain, if you find out, this is twice of your diametric side and single side of your longitudinal side, right? That is nothing but your, what is that one? Circumferential strain you have. So already you have calculated the circumferential strain, that is nothing but PD by 4TE, right? So twice of that PD by 4TE 2 minus mu. And what is your longitudinal strain? What is your longitudinal strain? So your longitudinal strain will be, just a moment, did I say something wrong? So simply if you'll do this one, twice of that hoop strain, how much you have? What is your longitudinal strain? Strain in longitudinal direction. What is that one? Then I think you need to calculate that one also. If you have a longitudinal one here and you have a hoop here, longitudinal strain will be sigma L by, I think little bit you have to invest your time here, mu times sigma H by E. Now longitudinal already we have, that is PD by 4T E, and minus mu times sigma H by E, that is PD by 2T E, and you will be getting here PD by 4T E 1 minus 2 mu. This is your longitudinal strain, right? This is your longitudinal strain. So longitudinal strain will be PD by 4TE, and that is also good. You have seen that what is the longitudinal strain. It is good that you have already seen that how you are getting the longitudinal strain here. PD by 4T, you keep 1 minus 2 mu here. Just you calculate and simplify this, and you will get, simplify this one, and you will get PD by 4T 5 minus 4 mu. Simplify this one, that's all. PD by 4TE, see here, 2 to the 4 minus 2 mu, and plus 1 minus 2 mu. See, 4 plus 1 will become 5, and 2 to 4. Did you get that? Did you get that? Any doubt, please let me know. Are you able to understand this? Okay, you have already written that longitudinal strain, PD by 4T. Abhishek and Kavya, both of you have written already, right? Now what about this one? For a thick cylinder, the radial, see this one, I generally recommend, this is Lame's equation. This is just I have given you so that you remember it. Based on this, sometimes you may get the numerical also, right? This is your Lame's equation for your thick cylinder. Lame's equation for your thick cylinder, isn't it? What is the equation of radial and hoop stress? Can you tell me? What is the equation for radial and hoop stress? This is first one. Please do remember, because now we are going to solve the equation based on, we are going to solve the problem based on this Lame's equation. Yes, Rahul, absolutely correct. Absolutely correct. The first one is your radial stress. Radial stress, you know that already, right? Radial stress. If you have a thick cylinder, the radial stress in the direction of radius, right? Internally, if it is P is the internal pressure. The internal radial stress will vary. How the radial stress will vary? I hope all of you have studied, already have gone through. Suppose this is the internal pressure. The radial stress, if I am talking about internal one, the radial stress will be maximum here, that is nothing but P, and it will be 0 at the outer one. Achha, 0 means actually the atmospheric you have, but we are considering as 0 because that is we are considering as a, that basic. So now you have internal pressure as a maximum internal radial, and outside you have a 0. Actually that will make your numerical easy, because that will provide you the boundary condition. And the hoop stress will be maximum at internal and minimum at outer one, but it is not 0. This is your hoop stress, remember it. That is the distribution of your hoop stress, and upper one is your distribution of radial stress. This is your radial stress distribution, and this is your hoop stress distribution. Did you get that? Now as a radial stress, we are saying that internal, so I can always write it down. The radial stress, suppose the internal, suppose you just complete this circle, right? So you have an internal dia as well as outer dia. So internal radius. So at Ri, internal radius, your radial stress Px will be simply P, the internal pressure whatever you have, and at outer radius your radial stress will be 0. That will help you a lot to find out these two constants, that is known as Lame's constant A and B. Simply use these boundary conditions, calculate the value of A and B, and whatever will be asked can be presented. That is the kind of problem you can get it for the thick cylinder. Are you able to understand this? Now here is the problem. A pipe of 200 mm internal dia and 100 mm thickness contains a fluid at a pressure of 6 Newton per mm square. Find the maximum and minimum hoop stress. It is not hope. We have a hope of getting good marks in examination. It is about hoop stress. Across the section, can you calculate it? Can you do the calculations? I told you the radial stress is nothing but what? B by you write down either by r square, right? R is varying from internal radius to external radius, right? Minus a. That is your radial stress calculation, radial stress. And the hoop stress I have identified by Q. Someone can write down by F also. Doesn't matter. B by r square then plus a. That is for hoop stress. What we'll do now? He's asking about the maximum and minimum hoop stress. Can you calculate that? Can you calculate that? The way I told you, use the boundary conditions which I told you in the previous slide. Use the boundary condition which I told you in the previous slide and calculate the value of A and B, that is Lamb's constant. The constant value can be calculated with the help of this, isn't it? He's asking what that? Maximum and minimum stress, yes. Calculate the values by using. So what will be the value of A and B? So I can say that these are the dia they have given. So I can say that at our internal radius, that is r equals to, at internal radius at r equals to, you have a 200 mm internal dia. So at r equals to 100, your px, that radial stress, will be how much? Internal pressure whatever you have, that is 6 Newton per mm square. Agree or not? Agree or not? And at r equals to, if the thickness is 100, the outer radius will be how much? If the thickness is 100, outer radius will be 200, right? At r equals to 200, what will be your radial stress? That is nothing but your 0. Now use these two in your equation px. Once if you will use this one, what's the equation? You will get it. Px is 6 equals to b by r square is nothing but 100 square minus a. One equation you have. Then another equation, use this one. At r equals to 200, px is 0. So 0 equals to b by 200 square minus a. Sorry, plus a. Oh no, why minus a. Use these two and calculate the value of a and b. How much you are getting the value of a and b? Can you tell me? How much you are getting the value of a and b? From here you will get a equals to 2, and b equals to 80,000. Now these two values you have to utilize it for the calculation of hoop stress. That's all. So now calculate your hoop stress. Hoop stress will be, what is the value of b? That is 80,000 divided by r square. Now at internal one you will be getting maximum, so better I should write down maximum hoop stress. Max. So if you are going to get maximum one, the internal radius you are going to use it, that is nothing but 100. So 100 square plus a value is 2. How much you'll be getting it here? Maximum 10 Newton per mm square, right? 10 Newton per mm square. 100 square, 1 2 3 4 will get cancelled. 8 and plus 2, that's 10. Simple. And fx minimum hoop stress you will get how? 80,000, same constant value, divided by outer radius. Outer radius is how much? 200 square. 200 mm is the outer radius, plus 2. And how much you will get? Here you will get 8. You will get 2 plus 2 4 Newton per mm square. Now the value is 10 and 4. The maximum and minimum hoop stress are 10 and 4. If you have any doubt, please let me know. Are you able to understand this? How to utilize the Lamb's equation for few of the problems. So remember that one boundary condition is always known to you, that is internal pressure whatever you have is the radial stress at that internal radius position. Use that one and get the values of constant. Once again, you will get the same type of problem. I have another one. Can you do this one? Here also this is hoop stress, not hoop. It is your hoop. Now this is kind of same problem. Same concepts will be required here. Let me count. Same concepts will be required here. Yes, I got it, Ramavat, I got it. Your that once again you need the explanation, but once again it is the same kind of problem. So instead of going for the same problem, you go for the another problem with same concept, isn't it? It will be better one. Find the thickness of metal necessary for a steel cylindrical shell of internal diameter 200 mm. I think it is 200 mm. 200 mm. Please use that 200 mm to withstand an internal pressure of 50 Newton per mm square. 50 Newton per mm square. Right, this is your 200 mm. Please use this one mm to withstand internal pressure of 50 Newton, and the maximum hoop stress in the section is not to exceed 150 Newton per mm square. So maximum hoop stress is restricted. This time the boundary condition, the way he has provided here, you are now supposed to utilize that one. He has given the maximum hoop stress, right? Find the thickness of metal necessary for a steel cylindrical shell of internal dia 200. You don't know what is the thickness here. Can you do that? Can you do this? Can you do this one? Try this one. Try this one. Try this one. So already I told you that radial stress equation, you have used it, B by R square minus C, and the which one, the hoop stress equation already have given. Let me write down that one here. Maybe Fx is nothing but your B by R square plus A. B by R square plus A. Now what I can use, the internal pressure he has given 50 Newton per mm square. If the internal pressure is given as 50 Newton per mm square, 50 Newton per mm square, what I can write it down? See, internal pressure given 50, so I can write down 50 equals to B by internal dia given. Are you getting my point? Internal dia given. Internal dia is 200 mm, so internal radius will be simply 100 square minus A. That is the one equation. I got it. Now you will be asking me, sir, can you write down the another equation? If I'll write down the another equation, B and A are unknown. If I will write down only the another boundary condition for a radial stress, what will happen? See, B and A, two unknowns I have. Another one unknown is our external diameter, that is outer radius. I don't have. I do not have the outer radius because I don't know the thickness of the material, right? So I will be having a three unknowns. So only with the help of that boundary condition, which I told you in the previous problem, one cannot solve this problem. So that is why they are very smart. They have given another boundary condition. That is what? The hoop stress in the section should not exceed 150 Newton per mm square. See, it is not important for you how you are solving it. It is not important for you that how you are solving it. It is important that what is your approach. What is your approach? After reading out the question, what exactly you are thinking. So generate a nice approach for that one, right? Now, the maximum hoop stress, that is why they have given that another boundary condition, right? Okay, you got it, 42 mm, that is great. So 150 is the final one, and where the maximum hoop stress will be? Where the maximum hoop stress will be? The maximum hoop stress will be at internal one, right? So B by 100 square plus A. Now here I can use these two equations. Are you able to understand that why I have not utilized the equation for 50 equals to B by outer radius square minus A? I am not going to use this one. These two are not the equation to use, because here by the red pen, with the red pen, whatever I'm writing down, try to understand that try to understand that if I'll use this one, I have unknown B, A and R naught, and only with the help of two equations I cannot solve this. So it is better to use 1 and 2. The equation 1 and 2 if you'll use, you will be able to get the value of A and B. You will be able to get the values of A and B. Now what will be the value of A and B by using? So using equation, solving equation 1 and 2, what is the value of A and B you will get? Can you tell me what is the value of A and B you are getting it? What is the value you are getting it? A is 50 and B is 10 raised to 6. 10 raised to 6. Now use these two values. Use these two values and get the value of, use these two values here. For the outer radius already you can use it here now. That is 50 minus B. B already you have that now. Sorry. Use it in third equation. Should I write down? Use it in equation 3. Use it in equation 3. You have a 50 equals to B value. You have already 10 raised to 6 divided by R naught I don't have. Outer radius I don't have. Minus A. A already you got it 50, and R naught how will we get, how much you are getting it here? R naught how much you are getting it here? 142 mm, right? Around 142 mm. Now this is your R naught, outer radius. Internal radius already you have that 100 mm. Internal radius already you have 100 mm. So what is the thickness now? Thickness of the material will be simply R naught minus R1. That is 142 mm minus 100 mm. Yes, 142 mm minus 100 mm. It is around 42 mm. You are getting 41 point something. Approximate values has been considered here. Yes, Abhishek, absolutely correct. Now what about this one? Axial deformation of closely coiled helical spring. This is very interesting problem. Very interesting problem. Closely coiled helical spring. How to solve this one? A closely coiled helical spring. How you will solve this one? See, for that, remember few things. See, if axial deformation, maybe they will be asking, or they may ask you the strain energy in the helical spring, right? Sometimes I already have given that. So they can ask you about the strain energy. They can ask you about the axial deformation. How you will be using that one? How you will be, remembering that one? Because remembering that, see, if you can remember the formula, that's great. That's always great. But if you have not remembered, how you will use this one? What you will do? Can you write down something? Can you write down something? Yes, I hope you are doing good. If you cannot remember the formula, follow my steps now. Follow my steps now. See, you know what is the strain energy for axial one? All of you please ready. What is the strain energy for axial bar? Now start from here. Strain energy for axial bar. Axial bar, if it is loaded with axial force, what is that one? Simple, no? P square L by 2A. Correct, no? From here also, I also used to remember. I don't remember this one. Now, strain energy for axial bar. Now, similar to that, you have a strain energy for torsion, right? What is the strain energy if a torsion is applied? If a torsion is applied, what is that strain energy? T square L by 2GJ. Is it okay? So similar fashion, no? That's what actually I am remembering from this only. Now understand one thing. This is your strain energy T square L by 2GJ. T square L by 2GJ. You have a helical spring. A helical spring are closed enough. It is not that much far I have given. They are very close. Ring over ring. Ring over ring. Are you getting the point? So if I'll say that the radius, this radius is R. If this radius is R, which radius? the ring which you are constructing, and the rings are very close, no more, not much helix are given there. Not much helix are given there. Now, if rings are there, this is your R. If I'll ask you what is the total length of the spring, so one turn represented as 1 turn. That's all. 1 perimeter. What will the perimeter here? Perimeter will be 2 pi r. Agree? No. Perimeter will be what? 2 pi r. If I'll say that n number of turns I have given, 1 turn has a length of spring 2 pi r. If I'll say that n number of turn has been given, what will be the total length of the spring? 2 pi r into n. Agree? This is what? Length of spring. Length, length of spring. So L I got it. Now T, what is T here? On a helical spring, I'll delete once again, I'll draw this one. On a helical spring, if you are applying a force here, suppose the force applied is some P. Now, due to the applied force, you consider any of the element from this position. In fact, all the elements will be subjected to the torsion. Now, if I'll consider any of the element from here, or maybe any of the element from here, consider that element, take it out. Take it out and just try to see that. This is your wire which you have rounded now. Now, this will be subjected to, everywhere they will be subjected to the P. P will be having, see, P is acting at center at radius R. So P into R, if you see here, a P into R, torsion will be applied to all over the spring element, right? To all over the wire, the P into R will be applied. Are you able to understand that this portion I have taken out, this portion I have considered out, and this is the scenario. Here it is actually subjected to the torsion, that is P into R, when you are applying the force P at this location. Now T also I got it. Now just keep all these values here. Just put all the values here, and if you'll keep all the values here, T is what? P into R, so it will become P square into R square. L is what? N into 2 pi R, N into 2 pi R divided by 2G, and J also you can write it down. It is solid, no? So J is what? Polar moment of inertia, isn't it? That is nothing but pi d4 by 32, isn't it? Pi d4 by 32. Simplify this one, how much you'll get? Simplify this one, 2 will get cancelled, and you'll get 32 P square R cube, what else, and N divided by G and D4. G D4. This is what? This is your strain energy. Now, as per the Castigliano, the axial deformation. See what Castigliano says, that force applied in this direction. You are interested to know what is the deflection, the axial deflection delta. If you want to know what is delta, as per the Castigliano, delta, the axial deformation, is nothing but del U by del P. Agree or not? Del U by del P. You do that one, del U by del P here. It will become 64 P R cube N divided by GD4. Now, either strain energy is asked to you or the axial deformation is asked to you. You will always be able to find it out. No need to remember that. Even though if you are forgetting sometime, you will be able to do this. At the same time, one more thing, you observe it from here. This is your deformation, deflection, and this, right? Now R is suppose at a constant radius. If you are making your spring, constructing your spring, and number of turn is N. D is your dia of your wire, whatever you are using it. G is the material property. So if everything is constant, I can say that delta is nothing but delta, the deflection of the spring, delta is nothing but your, what is delta? P equals to K delta, no? P equals to K delta, force equals to K delta, that is for the spring. So I can say that this delta, if you will keep it here, this delta value, if you will keep it here, force equals to what exactly you are going to get here. So just a second, delta, so K will become P by delta. Now P by delta, K will be P by delta. Now this delta, if you will keep it here, what exactly will become? Just a moment. From here we will find out one more thing, that is delta k equals to p by delta. So k equals to p divided by whole delta, you keep it here, 64 pr cube and divided by gd4. Now after simplifying that, you'll find that k will be equals to gd4 by pp will get cancelled, and here you'll get 64 r cube and n. Now if these are the constants, k is inversely proportional to n. K is inversely proportional to n. This is also a very important relationship. How the stiffness of the spring is related to the number of turn. How the stiffness of the spring is related to the number of turn. If the number of turn will be increased, the stiffness will decrease. If the number of turn will increase, the stiffness of the spring will decreases. If the number of turn decreases, the stiffness of the spring will increases. This is also very important relation. Remember that one. If you have any doubt, please ask me. Is it clear to all of you? Are you enjoying this? I hope so. Now here is another problem you have. The buckling load for a column pinned at both ends is 10 kilonewton. If the ends are fixed, the buckling load changes too. These are just very easy problems. These are just very easy problems. The buckling load for a column pinned at both ends is 10 kilonewton. If the ends are fixed, the buckling load changes too. So P critical, you already know that. What is that? What is the formula? Remember it. Try it. This is for the column. What is the formula for P critical? Pi square EI by L effective square. L effective square. If it is the buckling load for a column pinned at both ends, if it is pinned at both ends, the length will be L itself, right? Now P critical is given, that is nothing but 10. L effective is already L if it is pinned at both position. Now he is saying that if the ends are fixed now, if the ends will be fixed, P critical, I don't know, that will become P critical dash, that is nothing but pi square EI will be same, only L effective will get changed. If it is fixed at both ends, the effective length of the column will become how much? L by 2. Keep that L by 2 here. Keep that L by 2 here. Now, L by 2, if you keep it here, whole square, simply it will become how much? 4 into that pi square A by L square. Now pi square A by L square is already 10 given here. Keep that value 10 and the P critical dash will become 40 kilonewton. P critical will become 40 kilonewton. For a circular column having its end hinged, the slenderness ratio is 160. The L by D ratio of the column will be. What will be the L by D ratio of the column? So for that, you should know what is the relation. What is the relation? The L by D ratio he is asking, but he has given the slenderness ratio. What is the slenderness ratio here? Slenderness ratio. Slenderness ratio we are representing by lambda, isn't it? We are representing by lambda. That is nothing but L effective by R minimum. R minimum is what? That is radius of gyration. Radius of gyration. Isn't it? Now radius of gyration for a circular column you need to calculate. What is that radius of gyration you have now? What will be the value of radius of gyration? Under root of I minimum by A. I minimum by A. For a circular solid shaft, circular column, I minimum is how much? What is the moment of inertia? What will be the moment? Pi d 4 by 64. And what is the area? That is pi d square by 4. Now simplify this and you'll get d by 4. Now this is your R minimum. Keep it here. It will become LE by, and it is for a column its end hinged. Both end, if it has hinged, L effective is also L. So see this one. Both ends are hinged. So L effective also you take it as L. R minimum you can write down d by 4. It will become 4 4 L by D. Now that is given as 160. If it is 160, L by D will become simply 40. Did you get that? L by D will become simply 40. The ratio will become 40. What about this one? A strut of cross section 200 by 100 and length 3 meter is subjected to a gradually increasing axial compressive load till buckling takes place. Using Euler formula, determine the critical load here. Can you do this one? Using can you do this one? So cross section is given 200 by 100, where 200 is your width. 200 is your width, or no, it's strut. Okay, some cross section. So which one you will be using now? 200 and 200 by 100. 200 by 100 is given. Which one you will be used now? This is suppose your 100 and this is your 200. You will be using which one? Which I you will be using it? Tell me. I minimum, isn't it? You will be having 2I, BDQ by 12, BDQ by 12. The buckling always used to occur about minimum I which has. So IXX and IYY, you will be using the minimum one. So I minimum, how much you have now? How much you will be having I minimum here? I minimum BDQ by 12, just calculate it. I minimum will be BDQ by 12. So instead of this 200 into 100 cube by 12. By using that BDQ by 12, what is the value you will be getting here? So it will become 12 able to change to 1 2 10 raised to 6 और 2 8 10 raised to 8 mm4. That is your I minimum. Now he is asking what is the what is the buckling load, critical load, no buckling load. Now what a buckling load can be calculated? No, P critical you can calculate. P critical will be pi square EI by L square. That's all. Right. Now what is pi square? Then put the value of E not given. I'm sorry. I'm really sorry. Maybe it is here 210 GPa. I'm sorry for that one. 210 GPa. Pi square, then E value is 210 into 10 raised to just to change it to MPa, no? Newton per mm square. GPa to MPa you change it. Then multiply by I value, whatever you have, you keep it here 1 by 6 into. Are you getting my point? This is not very clear. Write down here. Pi square into 210 into 10 raised to 3. That is megapascal. Megapascal is Newton per mm square. Everything I'm keeping in mm only. Into I is 1 by 6 into 10 raised to 8 divided by L. The length of the column 3 meters, so use that 3000 as an mm. Use that 3000. Now what is the value you are getting? 3000 square, no? L square. How much you will be getting here? You will be getting around 3838.17 kilonewton. Now this is actually quite simple and easy. Next one is quite interesting, very interesting. You have already calculated the value of critical load. Now read this problem. This is quite more interesting than the previous one. Previous one was straight, just you need to put the values, calculative. Now the critical load is given with all the same information. It is kind of same problem here. The critical load, whatever you have calculated, is now given here. But what he's asking, if the yield point of stress for the given material is 270 MPa, sigma yield value is given. Determine the maximum center deflection if the both ends of the column may be assumed as hinge. And not capital, that is E equals to, this value is E. That's all. What will be the maximum deflection? Determine the maximum central deflection. What is the meaning? He's saying that suppose you have a critical load here, that is P critical, and this was your column position. If both sides are hinged, then he is saying that what is the maximum central deflection? That is what is the maximum central deflection? That is the value of E. This is your E. He is asking about that E. What value, what condition he has applied here? That you have a maximum yield that is 270 MPa. Material yield will be 270 MPa. Yes, I'm good. I'm good. Now, first of all, try to understand this problem. What he's asking now. What he's asking now. What you will do with this 270 MPa? That is the question now. What you'll do with the 270? Understand it. If you have a buckling here, now at this point where you will be having maximum stress. Now, this is your column position. At this position, you will be having P as well as P into E. Both you will be having. Are you able to understand that? If once your column is going to get buckle, the problem is that your one side, one face will be subjected to, one face of the column will be subjected to, actually the total face will be subjected to the compressive stress, and one face will be subjected to tensile due to the bending, and another face will be subjected to compressive once again. The problem will be always with where you have a maximum compressive one, right? Now, because tensile and compressive, they are going to get managed at one position, but maximum compressive also should not get increased, isn't it? So maximum stress which will be generated by these two are nothing but compressive stress directly due to the P and a bending stress. Now P by A is your compressive one, and the bending stress which is generated by that moment, both must not go beyond 270 Newton per mm square. Are you able to understand this? The axial stress and the bending stress should not go beyond a limit. Are you able to understand that? Material should not get yield. What is the axial one? You calculate sidewise. The values you can calculate always, no problem at all. Here you calculate P by A, no? P already is 3838.2 divided by area already. Area of the cross section area of the column, right? That is 200 and 100 given. So what will be the area? That area you calculate the area, that is kilonewton, so make it Newton divided by 200 into 100. If you do that one, how much you get? This is your P by A. I'm saying that this is your P by A. How much you're getting it? It's around, is it around 192 something coming? Now 192 Newton per mm square or something like that. Newton per mm square. Right. Now that is 192 Newton per mm square plus bending stress must not increase the value of 270. Now from here you calculate what is the bending stress maximum you have, that is 270 minus 192. And you will get how much? 270 तो में से 192 जाएगा कितना होगा? 270 minus 192 you'll get 78. Now that is the 78 Newton per mm square is your bending stress maximum which you can apply. Now you know already what is the formula for bending stress, right? So I'll write it down, that one. Bending stress already you have, right? So moment equals to, I know that the stress M by I equals to F by Y, right? M by I equals to F by Y, or I should say that I will go there. I do not remember that formula, and I by Y will be Z maximum, right? Z. So I can write down M equals to Fz. I'm sorry. M equals to Fz. So M equals to Fz. Now F will be M by Z. F will be what? Okay, or write down M P into the eccentricity is your M, and F is your bending stress, that is maximum allowed is 78. That's what, no? 78 is maximum allowed. And that, what is your Z value? Z value is your section modulus for the column will be BD square by 6. BD square by 6, use that one. Now BD square by 6, BD square by 6, and do not get confused. BD square by 6 means what? Which one is B and which one is D? Which one is B and which one is D? You know that already. BD square by 6. That is your section modulus. Use this one and calculate the, and P value already you know that 3838.2 into 10 raised to 3. You keep that value here. Do I need to write it down? 3838 0.2 into 10 raised to 3 into E. That is your total. That is just a moment. Must be equals to 78. Now calculate the E value from here. Calculate the E value from here. Are you able to understand that? You'll be getting around 5.05 mm. 6.4, maybe some calculation. I have taken that maybe 192. I think it is 191 point something, or maybe just you calculate few, maybe my calculations mistakes were there. How much you're getting? 6.42, or maybe it will be 6.42. My mistakes. Please calculate once again. I will also. It is your 3 point. Just a minute. 38.2 into 818 inverse 278 into 200. Yes, 6.42 mm. 6.7 I am getting it. It's almost around 6.5 or something like that. Yes, then A is not the answer, it is B. I'm sorry. B is the correct answer here. No, it's okay. Yeah, B is more appropriate. B is more closer to that one. Did you get that? That is how you can use the column also, right? Column. So sometime maybe you are feeling that column problems are easy. Not that easy. So meet me tomorrow once again for the deflection problem. Fantastic deflection problems will be there tomorrow. Not only easy, moderate and tough. All the problems generally I am bringing it down so that you will understand. You get the feel of gate. Gate doesn't provide you a very direct question. Yes, Neha, you are absolutely correct. 6.7 I am getting it. I am getting 6.7. So just close to that value is 6.4. I have marked it. Yes, you are right. Actually, I'm also getting 6.7. So gate always doesn't provide easy problems, right? 1 marks and 2 marks problems are there. Some conceptual problems will be always there, which required some. So calculation wise also you have to invest more time, and concept wise also. All of you please take care. Second question, you do one thing, you do it today, and tomorrow if you are still not able to understand, please ask me in the Telegram channel and I'll conduct once again tomorrow in the very beginning session. I'll take that, right? So Civil by Ansari Sir, if you are already there, it's okay. If you are not there, just join this Civil by Ansari Sir on a Telegram channel. Civil by Ansari Sir, and maybe in bracket you will find the surgeon. Join that channel, ask there, right? Till then, just do whatever you want to do. Thank you and good night.